Yay, people are there. Awesome. All right. Any questions?
Well, no, will we talk about what exactly shell functions or shell programs are?
Yep, we're going to talk about Git, and we're going to talk about, we're going to start some shell scripting today.
Cool.
Yeah, which will get us set up for the first big programming assignment, which we'll talk about on Friday. All right. I'll wait a minute for an attendance ping to give people a chance to get here. So let's, wow, why is this still going? That's weird. Let's just close that out. There we go. School stuff. All right. Let's start off by talking about Git. So I mentioned Git yesterday. Git is a system that we can use to do backups, but it's actually a lot more than just backups. There's this notion of source code control, right? So if you're writing a program, what do? You go into the editor, you create a file, and you type in some code, you compile it. Maybe it works, maybe it doesn't. You make some changes, you compile it again. Maybe it works, maybe it doesn't. You go away, you come back, you make some more changes, and eventually your program works. The next day you decide to add some new feature to it, so you make some changes. That's not a bad process to track if you're just one person. But imagine that you're developing code with a friend, or maybe two friends, and you're all working on the same program, right? How do you coordinate that? How do you avoid a situation where you start working on a feature that your friend is also working on, and when you're done, you've both written new code and only some of it is necessary because some of it is the same as what the other person wrote? Or you start writing a new feature and the changes you make to your program break something that your friend is working on. So coordinating code development among more than one person is tricky. And imagine now that you're working on a project with 1,000 other people, and this project is going to go on for a year, right? How are you going to coordinate all of this management of the programs that you're writing, the source code? So there are different versions of source code control. CVS is a really old one. Mercurial. There's a bunch of different systems that have been developed to help people manage large projects that are being developed by many people. And things you want to be able to do, for example, is pull out a chunk of code and work on it and make changes to it without having that affect other people. Because you're trying things out, you're experimenting, and if you've got some temporary changes in your code and that messes up somebody else, right, that's not good. So you want to be able to get your own copy of the code, make some changes, and then at some point sort of take that and move it back into the main project. You'd also like to be able to, for example, go back to an earlier point. Maybe you started down a development path and find out that's not a path I really want to explore. You'd like to roll back to where you were a week ago and see the code as it was. So source code control systems, or simply don't have friends to work with. That's a solution. Source code control systems are set up to help manage this in a controlled way. So when Linux was being developed, the team was using a source code control system that was pretty popular at the time. It was freely available. And partway through the process of developing Linux, the people who controlled this source code system decided, hey, we're going to start charging people for this because lots of people are using this. And they switched this from being a free product to something that you had to pay for to use. And you can guess how well that went over with the public, and in particular how well it went over with the team of people that were working to develop Linux. And remember, Linux was developed as this idea of an open source, free for everybody to use kind of mindset. And now they're being charged to use the software that they've been using for source code control. So they got a little upset at that. And so they created their own source code control system, and it's called Git. And it's probably the most popular source code management system available today. Lots of people use Git. Pretty much anything that you look at online, if the people want to make the code for their project available, there's going to be a Git repo somewhere. GitLab, GitHub, maybe their own Git server, but it's going to be built on Git. So we're going to use Git in this course, and 222 and 223 probably. You're going to use it for your own source code management, but you're also going to use it to turn in your projects. So you'll create a Git repository, and your projects will just be directories underneath that repository, and I'll be able to access the files from there. This also lets me do things like look at the history of changes that you've made to your projects, and it gives you a way to pull back older versions of your code. It also gives you something you can put in your portfolio, right? So a lot of people now, when they put together their resume or CV that shows their work history and experience and so on, they'll include a link to their Git repository and say, hey, here you can look at some of the projects I've been working on here, and employers understand what that is and so on. So we're going to use Git pretty heavily in this CS sequence. If you go to WSU, they use Git for most of their courses. So it's a really good skill to learn. So Git is free, it's open source, it's open access. You can use it on your own machine and have a whole history of your changes and so on and so forth. But there's also a cloud aspect to Git. So there's servers like GitLab and GitHub where you can take your Git repository and copy it into the cloud and then pull it back from there. And this is nice for a few reasons. One, it's a good off-site backup in case your hard drive fails or something. Two, it's a way to move code from one machine to another. So maybe you do your development work on the Linux machine, but also on your own Linux system at home, and you want to keep that code in sync. You can do that really easily with Git. And three, it's a way to share. So you can put your GitLab repo on a resume, or when we get to the team project, right, you can use Git to collaborate with your teammates while you're developing your code, and so on and so forth. So Git is good. It's your friend. It will make your life really good once you get used to the habit of using it, and it's not a really hard habit to get into. So let me run you through the basics of getting going with Git. And most of this is detailed in that how-to guide on Canvas. So let me pull that up. And some people have used Git before. That's fantastic. Some people haven't used it before this course, but have gone through the how-to and figured out how to make it work, and that's fantastic also.
I haven't really used it in a terminal setting, which is what you're about to do.
Okay, cool. So yeah, there's all kinds of graphical front ends to this. If you use something like Eclipse for development, it has plugins for integrating with Git and so on. The sort of lowest level way to do Git is through the command line. And yeah, if you download projects from the web, probably you're pulling down Git repositories, same thing. You're using Git. So a lot of this, we've already been doing and we don't necessarily know. So we're 10 minutes after. Yeah, so go ahead and send me an attendance ping. If you already did in the beginning of class, you don't have to send it again, or you can. But definitely send me an attendance note now. Let me know that you're here. So there's two aspects to Git that are related but sort of separate. The first one that I want to work with is just the idea of using Git on one machine. So I'm going to do some stuff on my Linux laptop here, and we'll go from there. So I've logged into my machine, and first thing I'm going to do is make a directory called new 224 code. So that's a subdirectory under my current directory. So if I do an ls, here's a thing that says new 224 code. Okay, so I guess I already had a new 224 from yesterday. So I'm going to change into that directory. So cd says change directory. So I'll change into new 224 code. And if I do ls, there's nothing in here yet. All right, so I'm gonna write some code. So I'll write my code.c. All right, so there's my first attempt at a C program. And it doesn't matter what files I use. Git is really just kind of a way to manage files. It doesn't really know per se about, C code, executables, Java, things like that. It's just a file management system. Okay, so I have a file here called my code. Now, very traditionally, whenever you're working with Git, it's common to have a file called readme. And so I'm going to make a readme. And the readmes are usually given an extension of MD. File extensions don't really matter in Unix. Typically, if you write source code for a C program, it's going to end with .c. If you write a text file, it might end with .txt. I have my camera program and the configuration files for that end with GPFL, but it's kind of arbitrary. It's just sort of convention. But readme.md is a standard thing to put in a repository. Now, MD is a markdown language. It means we can use plain characters like 2 asterisks, for example, to say, hey, make this text in between the 2 asterisks bold-faced and things like that. But it's just a text file. So this is a sample README for a sample repository.
Does .md stand for something funny?
It stands for Markdown. So HTML is called a markup language. This is a Markdown language. And there's different tags you can use so that when you look at this in certain viewers, like GitLab website, you can have formatting in your text even though it's a plain text file. But we can just take... Yeah, go ahead.
I'm currently at work, and I tried to run the assess command, and I got a socket error, java.net.connection exception, connection refused.
Yeah, because assess closed at 8 o'clock this morning.
Okay, that'll do it.
But if you're trying to see if you can...
I was trying to get to the next one.
Oh, okay, yeah, next one's not open yet.
So it's smarter.
Yeah, in some sense. Yeah, I'll post the next one tomorrow morning at 8, and that'll be due Friday morning. Alright, so I have 2 files sitting in my directory right now. I want to put these under the control of Git. So we're going to do a few things. The first thing you're going to do, and this is done once per project, is you're going to do an initialization. Okay, well, if you've never used Git before, you have to do these 3 steps. I can't do these right now because I've already done them, but git space config space -- global space core.editor space vi. That tells it to use vi as your default editor, and then your username, and then your email. So one time per project, you're going to say git init.
Can you give it a git ignore too from terminal?
Yeah, you can set up a .gitignore file in the top level directory of your Git repository, and then it'll ignore any files that match the patterns in there. Alright, git init, it says initialized empty Git repository in homenick new24code.git. Alright, you don't notice anything different if you do an ls. But if you do an ls-a, you'll notice there's a new directory .git. Alright, don't mess with that. That's really important. Alright, I'll tag that. Don't mess with .git. It's a whole directory structure with a bunch of files, with a bunch of gibberish and binary code and things like that. if you mess with that, you will probably destroy your Git repository. So it's hidden for a reason. It's hidden because it makes sense to Git. It doesn't make much sense to us. If you're tempted to look around in there and try changing things and so on, just make yourself a repository you don't care about. Go ahead and go wild in there. But if you're working on a project that you actually care about the files, just avoid that directory completely, right? And you won't see it normally when you do an ls. All right. So what is Git doing? Here's the idea. We have our file system. Is sitting in some directory. It could be a whole directory structure, you know, with subdirectories underneath here and so on and so forth. We have our files, and what we want to do is we want to put this into what's called a repository. Okay, so Git, there's a repository or a repo, and we want to push these files into here. And when we do that, Git will do some housekeeping that will, number one, record these new files as they are right now, but also will record how they're different from what you had in the repository earlier. And it will keep a history of everything you've pushed into the repo so that you can go back and you can look at differences, you can restore older versions, and so on and so forth. So our main task is to take our files and put them into the repository. We have to do this in 2 steps. Okay, there's something called a staging area. And the first thing we do is we push our files to the staging area. And we can push as many things over here as we want. We can push things multiple times and so on. This is done with the add command. So every Git instruction we do is going to be the word Git space followed by some keyword, followed by usually some arguments. So git add will put our files in the staging area. They don't actually push them into the repo yet. So let's add some files. So let's say git add readme.md. And it doesn't appear to do anything. But if I say git status, I can see, hey, I've got one file, readme.md, it's on the stage. And then I have one file, mycode.c, that I haven't done anything with. And Git is usually pretty helpful, right? It'll say use git add to include what will be committed. All right, so if I do a git add my code, it will go ahead and push that into the staging area. And then when we want to take what's in the staging area and move that to the repo, that's when we say git commit. So mostly just 2 commands we're going to mess with after you've done your initial git init. Git add, git commit. Git add, git commit. All right, so I'm going to go ahead and add mycode.c.
I have a quick question.
Yeah.
What does git push do? Because I recall using git push when I worked with Git a bit when I was doing an internship.
Okay, cool. So push is going to take us from this local repository off into the cloud.
Okay.
So we'll come to that in a few minutes. But yeah, that's the next thing after we've got it in our local repo. And that's where the fun starts happening. All right, so I have 2 things added to my stage area, but it says no commits yet, changes to be committed. Okay, committing means putting it on into the actual repository. And how do you do that? You say git commit. So I'll say git commit, and it will bring me into an editor window. Okay, so I'm inside VI, and everything that starts with a number sign is a comment. And it's telling me, you know, please enter the commit message for your changes. Line starting with a number sign will be ignored. And what I'm about to commit are 2 new files, readme.md and mycode.c. So there's you know, whole online discussions you can read about what a good Git commit message is for Git. Too often we just, you know, write something like, you know, a period. Or, you know, committing changes or stuff or something like that. But as you go forward, it becomes useful to actually write decent commit messages. But for my first message here, I'm just going to say, this is my initial commit of a test repository. All right, so I'll save my changes, and it tells me, hey, 2 files changed, 9 insertions, created, and I'm done. None of this changes what I see in my directory. None of this changes my files. All right, but if I say git status, it tells me now there's nothing to commit, working tree clean, that's good. If I say git log, it will show me a history of what I've done. In particular, at 10:19 on Wednesday, I made a change that I said initial commit test repo.
Real quick.
Yeah.
Can I say something? If you don't feel like going through the long and arduous process of saving your VI, when you do commits, you could do git commit -m and then quotations and then just put your commit message in there. And then
Yep.
it just bypasses all that.
Perfect. So let's change my code.c. So I'll go ahead and put that in. Okay, so I can say git add my code.c, git commit, and if I do git commit, it will bring up that VI window, right? So all of these commands have a bunch of options, and one option on commit is I can just put my commit message right after a -m switch. So I could say add stdio to file. And then I don't have to actually go into VI. And now everything is clean, and if I do a git log, I see two things in my log file. I see that at 10:21, I made a change which I tagged as adding standard IO to file, and at 10:19 was my initial commit in my test repo. So this will keep track of everything, and I could go back and look at my files as they were at this point. I can go back and look at my files as they are now, and so on and so forth. We're not going to go too far down that path today, but this is the basic setup of making a repository in my local system. Okay? But all of this work that I'm doing is recorded inside this subdirectory named .git. And if I do something like, for example, I accidentally delete this entire directory, everything is gone, right? My files, my Git repository, my history of changes, it's all gone because it was all sitting inside this directory. So we still have some exposure to user error, right? Or to, you know, catastrophic failure of our laptop or hard drive and so on and so forth. So this is useful if everything works the way it's supposed to. But we still want to go beyond this. We want to look at how we can use Git in the cloud. So this will take us to the subject of GitLab. All right, so GitLab it's a website. So you can go to gitlab.com, and if you have never used this before, it will give you an option to sign in or to create an account. So you want to create an account. Pick a username that you won't forget. Use a real email address because it'll communicate with you through email. But you can pick whatever account name you want, and so on and so forth. All right. So when you do that, you'll come to a page something like this. These are all of my projects. Okay. And you know, I've been using this for a number of years, so I have a bunch of projects going back. Some of them updated pretty long ago, some of them updated pretty recently. And if you click on a project, it brings you into something that looks like your directory view, right? This project corresponds to a directory on my laptop called SLP2021, and I have a directory named doc, IOTests, AIO data, and so on and so forth. But I have a copy of that directory structure here. Okay, I also have a history. So I can see all the different changes that I've made to this. And this was, you know, changes I made in September 18th, September 13th, a bunch of changes on September 2nd, and so on and so forth. And at any point, you know, I could click on one of these and start digging into details of what my code looked like at that point. And so there's all of this access through the website, but again, we're not going to worry too much about that for what we're doing in here. Mostly, we're using the website as a way to just take what exactly is in our repository on our own system and make a copy of it in the cloud. Mostly so that I can download it and take a look at your assignments and so on and so forth. So you have to do a little bit of initial setup to make this work. So, first thing you need to do is this is totally one-time stuff. Okay, this is one time forever. It's not once per project or once per quarter. This you do once, and you're pretty much set until you get a new laptop or something like that. So you can do things with GitLab by putting in a password and a username, and that's a pain, right? We don't want Git to slow us down. We don't want it to get in our way. Okay, that's my 2 edicts about computers. Don't get in my way, don't slow me down. So if every time that we want to push our code over to GitLab, we have to type in a username and a password, that's no good. So what we do is we set up a secure method for exchanging information with GitLab in such a way that it knows that we are who we say we are without having to type in a password. So this is done through a public-private key setup. And so you have to do this one-time setup. From your Linux machine, you want to type in SSH keygen TRSA B4096-C and put in your email address. Okay, I'm not going to go into the details of what this is doing or how it works, but this is going to create a very long pair of files called a public key and a private key. And the basic idea is that you're going to know both the public and private key. The rest of the world is only going to know your public key. But by knowing your public key, somebody can find out if you also know the private key. And that's how you authenticate yourself. And you can do this for logging into machines. You can do it for pushing things to Git. You can do it for transferring files from one machine to another, and so on and so forth. We'll get into this in CSE215.
I have a question. Like, if I have I juggle between 2 and 3 machines.
Mm-hmm.
Can I set this up for each machine so that way, or is it sort of like I can only really sort of do this for one? I have to do it the annoying way for the other ones.
Nope, you get to do this for every machine.
Okay.
And so if you do this on your laptop, you do it on the Linux server, you do it on your desktop, then any of those can push to Git or pull from Git without having to type in username password.
Okay.
Yeah, that's exactly what the goal is, actually. All right, so type in this command. It will ask you to specify something else. Just hit enter. It'll prompt you 3 times. Hit enter 3 times. If you've already done this once before, it'll tell you that you're about to overwrite a file. In that case, you've probably already got an SSH key set up, so don't worry about any of this. All right, so type in this command. Hit enter 3 times. And it will create a pair of files under this directory, ~/.ssh. So I can go ahead and do this.
Since we're on an SSH server, you only have to do it once, right? Because you're technically on the same, server, laptop, whatever.
Well, when you do this, it'll ask you which file you want to save it in, and I'll just take the default. But it's going to tell me that it already exists. I don't really want to overwrite it. But if I did say overwrite it, then it would go ahead and it would ask me for a passphrase, hit enter, it'll ask for the passphrase a second time, hit enter again.
Should we do this on our ENGRCS server accounts?
You should do this on Linux, engrcs.com, because you're probably going to be developing code from there. If that's where you're going to do your main development. Okay, if you're going to do your main development from a home machine, do it on your home machine, or do it on both. The only trick is if you try to use Git from more than one machine, it's a little easier to get into trouble, but not too much trouble. And we'll talk about how you can get into trouble and how to get out of trouble. So yeah, I would do it on any Linux system that you plan to be using for this course.
Throw it on my WSL as well then.
Oh yeah. All right, so after you've done this, go into this directory, ~/.ssh. And if you look in there, you'll see a bunch of files. You'll see at least an IDRSA and an IDRSA.pub. You may see some other files, so authorized keys, known hosts, and so on and so forth. All right, so I'm going to cat IDRSA.pub. This is the public key. This is the key that you're going to share with other people. And it's, you know, a big long string. And this string somehow uniquely is associated with the contents of ID_RSA. This is your private key. You don't want to share that with anybody. I don't want to put it on my video that's going on YouTube. But this is a private key. This is the public key. And they're bound to each other. Now, you cannot figure out the private key by knowing the public key. Not yet. The day you can do that, the world changes forever. Because that's the whole basis of e-commerce and most security that we rely on today, is that knowing this, it's not possible to figure out the contents of this. But it's not impossible. It's just really, really hard to do. All right, but somebody can use this and can ask me, hey, are you really Nick? And I can answer that question using what's in this file. And they can confirm that I must have known the contents of this file in the answer that I gave. So this is the key to authentication. So what you're going to want to do is copy the contents of this file. And if you're typing this out on console, for example, this terminal program, just highlighting it automatically copies it to the clipboard. And then you're going to go into GitLab and you're going to paste it somewhere. All right. So you've set up a GitLab account. Click on your picture on the upper right, select Settings, go down to Security or SSH keys, and you'll see a window that says Add an SSH key. So let's do that. So I'm going to click on my picture. I'm going to find, yeah, maybe that's not where to find it. Let's look on the left. Let's find Security. And I'm pretty sure these things change like all the time on me.
If you click on Preferences, it'll pop up on the left side in a window.
Excellent, thank you. All right, so Preferences, and then down here you can find SSH keys. And what you'd want to do is go ahead and paste your key into here and then say Add Key. Now I've already pasted this key in here before, so I'm not going to do that. But you can see I have a series of keys that I've saved. This is one for Clark. This is one for my Raspberry Pi on a project. This is a VirtualBox one. This is my main laptop, and so on and so forth. All right, and these are public keys, right? There's no danger in somebody seeing these because they don't give them access to the private key. I got too many keys on here.
So if I wanted to use two different machines, I would add the keys for both here, correct?
Exactly, yeah.
Okay, gotcha.
And you can name them whatever you want to help you identify them. But pretty much once you put the key in here, you're done. You don't have to worry about this anymore. And you know, this thing, whatever main was, I created 5 years ago. I've never gone back to think about it. This one probably doesn't even exist anymore. But they don't expire by default, so. All right, so that's a one-time setup. You only got to do that once. And so let me go back to our project that we're developing. Okay, so per project we had to do one time git init. Okay, and then we said every time that you make a change to a file, git add, git commit. All right, there's another one time per project setup that you have to do if you're going to work with GitLab. You have to associate this directory that I'm working in with the repository that you want to create on GitLab. So let me go back to where I was. Nope. Where was I? Alright, so this is where I was. So you got one more command to make. This is a git remote add origin. So this command right here. And this is where most headaches begin. Git remote add origin. Git at gitlab.com colon, and then your GitLab user ID. So it's not your Linux login, it's your GitLab user ID. Nick Macias / and then what you want to call the repository on GitLab. So I don't know, I'll call this new 224 code, and then you have to end it with .git. All right, so this will be different for you, right? Git remote add origin, still be git at gitlab.com, but it'll be your GitLab username / and then your name of your repository. And I think for homework 2, I asked you to call it CSE224. So whatever the instructions say in there.
And we have to do this whenever we make a new project.
Whenever you start a new project, you need to do the git init and the git remote add origin commands.
Okay.
But all of your projects for 224 are going to be in the same repository. So you're only going to have to do this once for the entire quarter. Because you're just going to keep making new subdirectories under your main 224 directory. So you do this once, and once it's working, you're good to go. All right. If something goes wrong here, if you try to do what comes next and it's not working, and you want to type something in different, it's going to complain remote origin already exists. So you can undo this by saying git remote remove origin. That undoes the git remote add origin, and then you can try adding again. So if you made a typo or something, you got to remove what you already typed, and then you can go ahead and make the correct add. All right, so let's go ahead and look at my projects. And I'm doing this off screen because it's also going to show me your projects in some cases. All right, so here's my personal project. So the last one I have was uploaded 2 weeks ago. That was a backup of last year's work. Git init one time, git remote add one time. Okay, going forward, git add, git commit, git add, git commit. Anytime you want to push your changes over to the server, it's one more command, git push origin master.
You
All
can
right.
do that for other branches too, right?
Yeah, we're not going to get into branches today, but yes.
Okay.
All right, so git push origin master gives you a bunch of stuff and no error messages. So now if I come back to my projects, there's a new project, new 224 code. And if I look inside there, there's a README and there's a my code. And it will show me what the README is down here. And I can click on my code and I can see what my code looks like and so on and so forth. And I can look at history and I'll see my history of 2 commits, my initial commit and my added standard IO to file and so on and so forth. All right, so let's say I make a new file. All right, which had a typo in the name. So I can add that, git commit with a bad commit message, and git push origin master. All right, now if I come back and I look at my project, I got a new file. All right, so once you get this set up, setting it up can take a really long time to get it all right. Once it's set up, it's pretty painless, right? Git add, git commit, git push origin master. Those 3 commands. Just keep doing those every time that you want to push your code over, and it will keep things in sync and so on. This has on more than a few occasions helped students save a failing grade with me. Because, for example, I had a student once who you know, I wasn't doing slip days. I had hard deadlines, and the assignment was due at 8 o'clock, and they wrote me at 9, and they said, you know, I just lost all of my code, and I'm trying to get it back, but I wasn't able to turn my code in on time, right? And I was able to go and look at their Git repository and see, you know, that at 7 o'clock in the morning, they had their project done and it was working perfectly. And they were trying to add some final comments to one of the files, and that's when everything got lost, right? And so I was able to see that they weren't, you know, doing this at the last minute. They had worked on it steadily throughout the 2 weeks and so on and so forth, and I let them turn it in a little bit late, and they got full credit for the assignment, right? So I mean, this is good in so many different ways. It's good documentation. I've had cases where two students turned in the same code, and one of them had, you know, a Git repository with steady work being done throughout the entire week, and the other one had a repository that was created, you know, the day before the assignment was turned in, and had no history except, you know, here's these files that work perfectly, and it was pretty clear which student had copied from which. So it's good documentation, and like I say, if you're going WSU, a lot of the courses will grade you on your Git repository. They'll grade you on what your commit messages are written, what style they're written in. They'll grade you on how many commits you've done, how you're managing your Git repo, and so on and so forth. So it's all win for you. All right, so we'll add the cloud out here. So we'll have gitlab, and basically you can say git push to go into the cloud. All right, new 224 code, okay. So let's say I'm on the Linux machine, and, you know, all right, I'll get rid of all that stuff. Let's say I want to take all this work that I've done on my laptop and move it to the Linux machine. Okay, I can do this with one command. I can say git clone, git at gitlab.com :Nick Macias / CSE224 code .git. But I gotta spell it right. New 224 code. .git. And guess what? It just made a new directory for me. And in that directory, I find my 3 files. And it's got, you know, all the contents in there. And also, if I say, you know, git log, I've got my whole history of changes that I made and so on and so forth. So this is an exact copy of my repository from my laptop sitting on the Linux server. And let's say I make a change over here. All right, so that's a little better. All right, so I've got new code in mycode.c. Git add mycode.c. Git commit. So I've got compilable code. Git push origin master. All right, now these new changes are pushed over to GitLab. And if I come back here on my laptop and I want those changes, now I can use git pull. Right? So here's what I have in my directory, git pull origin master. And it'll tell me, hey, it made a change to mycode.c. If I cat mycode.c, there's my new version of the file. If I look at the log, I can see that, you know, I made my typo commit message on Wednesday at 10:43. I did that on the Linux server instead of here. It doesn't matter. I've got an exact copy of the repository. So be a little cautious for now with doing this pull business. This can get us into trouble. But for the most part, if you're just working from one machine, right, you're going to do git init and git remote add origin once. And then every time you make a file, you're going to say git add, git commit, and then git push. And if you're just going in that direction all the time, pretty hard to get into trouble. What can go wrong is you start pulling things but you've also made some changes over here, and you start trying to pull things that don't take those changes into account. So we can get a little tangled up working with more than one machine on the same repository. We'll dig into that later, but for now, all you need is that one direction. So let's see, it's giving me an error saying it's not a Git repository. Not enough information there to know what to say about that. Make sure you say git init though. That may be why it's complaining. So you got to do git init first. So let's take a look at homework 2. This is due on Friday. As I mentioned, it will take, about 5 minutes to do this if nothing goes wrong. But the purpose of this homework is to figure out how to do these steps. So what you want to do is on the Linux server, make a directory called CSE224. Okay, and you're going to put all of your CSE224 work under that directory, usually in other subdirectories. Okay, go into that directory. So cd space CSE224. And then from that directory, do the following. Do git init, and then touch readme.md, or you can vi it and put some stuff in there. But touch will just create an empty file with this name. And then do git add, git commit, and then git remote add origin. Use your gitlab username here, and call the repository CSE224.git. If you've already done this and something is messed up, you can always go to GitLab. You can delete this repository from GitLab and sort of have a fresh start. If you want to delete a repository,
you just do like git commit add blah blah blah, but instead of add you use remove, right?
that'll let you remove a file, but if you want to get rid of the whole repository, just say I had done this and I decided this repository is totally hosed. I don't want to deal with it, I just want to start over. Okay, so from your project, go to Settings, and then come down to the bottom to Advanced Settings, and then come all the way to the bottom and you'll find the Delete Project. And to delete the project, you have to type in the name of the project exactly. They really don't want you to do this by mistake, right? Because you can't undelete. So I want to delete this. I'm going to say, yes, delete project, and now it's gone. All right, so homework 2. So do your git init, make a readme, git commit, git remote add origin, git push origin master. That should make a repository in your GitLab account called CSE224. Okay, next thing you want to do is go to that project. So let me pick a different project because I just deleted that project. Go to that project. Find project information, members. Click on that. And find me by name, so Nick Macias. And you should find Nick space Macias at Nick Macias. Okay, it should be pretty unique. And then select a role, add me as a reporter. This will let me look at your code but not modify it. And then go ahead and say invite, and that's all you need to do. And you need to do that once for the entire quarter also, because you're only going to have one repository. So go to GitLab, find your project, add me, Nick Macias, with the role of reporter, and now I have access to your repository. Okay, now go back into your CSE224 directory on the Linux server. Make a new directory called homework 002, that's this assignment, and in there make a readme file and just tell me a sentence or two, tell me what you've done with Git, whatever you want to tell me in there is fine, just add a couple of lines to it. And then git add, git commit, git push, right? And that's all you got to do, those 3 statements, that will take that whole subdirectory and push it over to GitLab in a way that I can pull it down and read it. And then you got one final step. I need to know what your GitLab user ID is. And you're going to do this by sending me an email on the Linux server. Okay, and this is not something we're normally going to do. Normally I want you to send me email nmacias@clark.edu from whatever your mailer is. But you can also send me mail on the Linux server. And this makes it a little easier for me to set up. So how do you do this? You say mail Nick, and it'll ask you for a subject, and I want your subject to be one line, uppercase GIT : space, and then your GitLab username. So I would say subject git : space Nick Macias. Hit an enter. And then just enter a line containing a period and hit enter again. So just type a period, hit enter, it'll tell me null message body, hope it's okay, that's fine, you're done. You can log out, you're done with homework 2. And that's also something you only need to do once for the entire course. So all of this is set up, it's one-time pain, but once you're done with it, you're good for the next 10.5 weeks. Alright, so that's due Friday morning. Go ahead and follow this, come back to the video if something didn't stick. Try to get this working. If it's not working by tomorrow morning, come by office hours and we'll get it working Thursday morning. Alright, sound good? Cool. Send me one final attendance note. Yeah, question?
Oh, no, sorry.
Okay, cool. Alright, send me your attendance ping. You're good to go. I'll see you next time. Thank you.
I have one little quick question.
Okay, go for it.
Let's say we're going to use GitLab as our repository hoster for this class. Is it something could we use like the GitHub GUI desktop app if we wanted to like just review the repository and then publish our changes?
Yeah, you can do that.
Ah, sweet. Cool.
But definitely know how to do it from the command line also, just because it'll show up on like tests and stuff.
Exactly. All right.
Cool.
Have a great day.
All right, thanks. You too.
But sorry for interrupting, Corbin. I just wanted to ask if after the quarter we'll be able to still access our repository for the class and stuff.
So I tend to keep the accounts on the Linux server around until August. So even if you're not taking 222 and 223, yeah, your login should still be intact.
So, is there a way of like taking your whole repository from like class done and then like transferring it to another repository, like for a personal account?
Yeah, so you got a number of options. You could use Git, for example. The usual way would be to make an archive. So there's a command called tar that we'll talk about later that will let you take your entire directory structure, including, the timestamps for your files, permissions, all that kind of stuff, and build it into a single file. It's kind of like a zip file. And then you could download that with SFTP or WinSCP or some other program of your choice to copy that to another machine and then just untar it there. And that'll get you a copy of everything you've got on the Linux server. And we can go through details of that another time.
I have a quick question, Nick.
Okay.
So when I tried doing the commit command and it opens up the VI window, so what was the command to fully commit? Because when I exited the VI editor, it just said did not have the correct command to fully commit it.
Yeah, you have to type at least one character in the message.
Okay.
So if you just :Q or :WQ, it'll give up on the commit.
Okay, so just type anything in the VI editor.
Yeah, and I usually just type a period and I'm done, but that's not a very good habit. But that'll get you through the commit.
Okay, thank you.
Because when it says username, when you do the initial Git setup, does that mean it wants the username that you put in your GitLab right away, or does it just want you to do the username, email, like keep it like anonymous and then do it later.
When you're doing the git remote add origin?
Git config.
Oh, git config. Yeah, that's your GitLab user ID.
Okay.
I don't think it has to be, but it's easier if you make that the same as your GitLab.
Is it also so? Can there also be spaces in there? 'Cause, like, I think I just.
I would avoid spaces in anything related to computers forever. Most
Well, I guess it's a bit late for that.
most systems seem to work well with them, but I still get tripped up in Windows sometimes, and I still get tripped up with some pieces of software sometimes, and it's a little risky sometimes. So change them to underscores or use camel case or just slam everything together or something. But yeah, generally avoid spaces.
Okay, because I also tried to do that git push origin master, and it says like origin does not appear in the git repository. Does that mean I just haven't like made the account yet correctly?
It could be that, or the git remote add origin might have had a typo in it. But mess around with it. Take a look on GitLab. Make sure that you can log in and so on and so forth. And come by office hours if you want. That's going to be easiest. We can just look at it on your screen and figure it out.
What was office hours again?
Every day, Monday through Friday, 8:30 to 9:30.
Okay. Alright,
Except next Monday.
Alright.
All right, cool.
Thank you.
Yep, have a good one.
Thank you.
Thank you, Professor.
All right,
Have a good day.
you too.
Thanks for the lesson.